So we'll see the relevant theory for this understanding this time value of money. First thing is about the simple interest. Of course, simple interest is a age-old concept, and always for simple, the simple interest is easy to calculate the interest and pay the money. There is still sometime in practice and at least in some villages and all, but in banks and all, they are using this compound interest that we should know. And say here you are giving a money of P. Of course, the terminology, let us see. This P refers to present value and F refers to future value. And I refers to fractional interest rate. There is percentage. Simply they call interest rate, which is reported as percentage. For calculation, we will use the fraction. Say 10% means the fraction is 0.1, right? And N refers to this number of period. Most often, this N is year and I is interest per year. Okay. Now, say this P is a present value of your money, and for that, how much interest we are getting? The interest per year is P multiplied by the fractional interest. So there is an amount of interest added per every period. So if I say if the I is interest per year, interest rate per fractional interest per year, then P is already the present value. That P multiplied by I, there is an amount of interest you have to pay for the principal you have taken. So this interest is a constant for every period. So your F will be coming like this, F equal to P into 1 plus IN. This is I is a fractional interest rate, N is a number of years. So is how this, initially you have this P as a value, and of course at that start of the year you have F and P are the same, and at the end of 1 year to the principal we are adding this P into I. That is a this amount is nothing but the interest for 1 year. So your P into P plus PI will be equal to P into 1 plus I. And again, that's the principal is now remaining the same. So already you have in the first year you have added this amount. Now in the second year you are adding another PI amount. So your future value at the end of this 2 year will be P plus 2 times PI. So otherwise by at the end of N year, F is equal to P into 1 plus IN or NI. Okay. And the compound interest, what they are doing, of course, initially you have P, and at the end of N years, you'll be getting F. And how this F and N are connected, F equal to P into 1 plus I to the power N. So the difference is here it is F equal to P into 1 plus IN, I into N in multiplication. Here it is 1 plus I to the power N. Of course, this is a formula we are using for simply for calculating the future value. This is simply no longer useful. Of course, no longer used, not useful, still being used rarely. Whereas this formula used for calculating the future value in the banking terms. And how this amount is growing like this. Now, so initially you have P, and to the P we are adding interest, which is P into I. Of course, this is very similar to what you got for the first year with the simple interest. For the second year, what happens? So the present value of the money is now turning to P into 1 plus I. So to that value, we are adding an interest, which is again this amount multiplied by the interest rate. So this is the amount at the start of the first year. To that amount, we are adding a interest rate. This multiplied by the fraction, you'll be getting. So this is a value you'll be getting at the end of the second year. So this again you can reduce and you'll be getting as 1 plus I to the power 2. This is for the this is at the end of second year, and this at the end of nth year. Now, we are not doing only this one-time investment or one-time getting the money. So we are also getting this, making this investment periodically, or what is called as periodic deposits. Every at the end of every period, we deposit some amount, say as uniformly the amount of A, and what is the future worth of that periodic deposits. So they are connected by this way. Of course, you can also derive this. The derivation I am not giving here. So this F, there is a future value at the end of n years is equal to the periodic payment amount A. This we call it as annuity, because n is the every period we consider as a year. Of course, the formula whatever you get is also applicable for monthly payment or quarterly payment or anything. So in that case, your n will be number of quarters, and I will be interest per quarter, or is fractional interest per quarter, or is simply we take it as year. So this n refers to number of years, I is the interest rate per year, and A is the periodic payment amount. Of course, this formula is based on the deposit made at the end of a period. Say this first amount is made at the end of first year. Second amount is second A is spent at the deposited at the end of second year. So this is what is called as a ordinary annuity. There is a formula whatever you whatever is available here is for the case of A made at the end of a payment period. But sometimes, of course, in our Indian system, we are actually starting the payment from the 0th month itself. Or A is made at the start of a payment period. Say we are making the payment at the start of the first year, which means 0th year. And after making the payment for n-1 times, of course, n-1 plus we are making n times payment is made. And we are waiting for one more year so as to get the F, future worth. Service, the amount of A made here and here are the service number of times A made deposited here and here are the same. But what is happening in this thing is the payments are made at the end of a period. Here the payments are made at the start of a period. So since it is made at this n-1, we will be waiting for one more term, and so as to get the future value of F. So this formula, which is called as the ordinary annuity, and this formula is what is called as the annuity due. Since we are waiting for one more term, whatever the amount is there, this is this amount, that multiplied by the interest for that for that we have to also add the interest, no? This amount plus that into I. That will be the future worth at the end of n years. Of course, this is this kind of formula is not used in the usual books and all. They simply say like future worth of periodic payment means only this formula, and they call it as ordinary annuity. Of course, there is no mention also. You take it as ordinary annuity. But in our Indian system of this banking, we make the deposit at the start of every period, and we will take the maturity at the end of the period. So this is what is called as the annuity due formula. There is the same formula, which is again multiplied by 1 plus I. There is one more term. We are getting this. This is not easily applicable. No? Once you make a deposit and again withdraw it. So what is the purpose of having this, adding this thing? So instead, you can need not have this and simply calculate for this n-1 times. Whereas this is more applicable in our kind of recurring deposits in Indian system. Of course, I'm not sure whether this kind of banking practice is there in other countries also. At least I'm no aware of this Indian system. We are depositing this A at the start of every period, and after then we are waiting for one more time to get the maturity value withdrawn. Okay, so this formula is called as the annuity due, future worth of periodic payments for the annuity due problem. That is, this is A are made at the start of a payment period. And here A are made at the end of a payment period. Okay, now these days people are making not deposits, instead they are getting a loan and repaying that, what is called as by the way of EMI, equated monthly installment. So for that, actually what we are getting, the loan is amount is P, that is a present value of your money, that after getting that we are going to pay that periodically, this uniform equal, what is it, EMI refers to equated monthly installment. No? Of course, here we simply call it as N as years. Otherwise, at the end of every year, we are making a deposit of, otherwise, we are repaying an amount of A uniformly. And to calculate this, or is to relate this P and A, we have this formula P equal to A into 1 plus I to the power N minus 1 by this I into 1 plus I to the power N. Of course, this formula and this F, no, is from F, we should be in a position to get P, right? Let us relate that here. So, you know the connection between F and P. What is the connection? F equal to P into 1 plus I to the power N. So, you can also compare this. So, this F, this is your F, and how to get this P, is to the P. To get P from F, simply divide the F with 1 plus I to the power N. So, that's what is the formula here, no? This divide by I, that is your F. F divide by 1 plus I to the power N, so as to get F, P. This formula is applicable for one-time payment, and these are all applicable for periodic payments. Of course, to connect this, to get this formula, it is enough to know this future worth of periodic payments. Of course, the payments are made at the end of a payment period. So here also, now we are getting a loan amount P, and that loan is repaid at the end of a period. Okay. So otherwise, it is enough to know this simple formula. Otherwise, one formula which is F equal to P into 1 plus I to the power N, and another formula for periodic deposit which is F equal to A into 1 plus I to the power N minus 1 divided by I. And using these two, we can get this formula. This is nothing but present worth of periodic deposits. Actually, this A refers to periodic deposit or periodic withdrawal, whatever. And usually people used to have this interest order at the end of a year. And these days, they are also adding this interest too frequently. Say like this monthly addition of interest, or what is called as monthly compounding, or sometimes quarterly compounding. So these kind of interest addition practice also being happening. So for that, what is the formula connecting this? Is how to calculate the interest. No? So this I refers to the nominal interest rate, nominal annual interest rate, and NC refers to number of compounding in a year. Say what is the number of compounding? Say for the case of half-yearly compounding, it is number NC equal to 2. Otherwise, every year interest is ordered at the end of 6 months. And quarterly compounding, number of quarters are 4 in a year, and monthly compounding, there are 12 months in a year. And as like that, we can also do daily compounding. And why to do this? We can also have a continuous compounding. So in that case, this formula is simply coming as exponential of I. So of course, this 1 plus I by NC to the power NC. Here the NC is taking a infinite thing, infinite value. So of course, you cannot easily get this in your calculator. Of course, that mathematically is equal to exponential of I. So this I refers to nominal interest rate. And how they specify this kind of problem? They say like 12% interest compounded monthly. So what is the meaning of that? This I is 0.12, and compounded monthly means there are 12 compounding period in a year. So NC is 12. So 1 plus I by NC whole to the power NC, that is equal to this is a that is equal to 1 plus I effective. That is I effective refers to effective annual interest rate. say otherwise in the case of say this we can easily understand. Say for the case of NC equal to 2, because there are 2 times interest is getting added, so 1 plus I by NC will be 2 here, and this NC is 2, so 1 plus I by NC 1 plus I by 2 divide that whole to 2 equal to 1 plus the effective annual interest rate. And related with this is people also say like these days they say like monthly interest or quarterly interest or sometimes daily interest. So how the monthly interest means this IM refers to monthly interest fractional interest rate 1 plus IM. So since every month we are adding interest, and what is the future value at the end of a year, what is a risk this P into this will be coming like your future what no risk this multiplied by the principal will be getting the future value. So here 1 plus IM to the power 12 that is equal to 1 plus I effective. I effective is the effective annual interest rate, and IM will be, of course, what is IM? That is also equal to nominal interest. This IM you can also get it from this effective what is it? Sorry, nominal annual interest rate, which is I. Of course, this 1 plus IM, there is monthly interest and nominal interest compounded monthly. This IM is simply equal to I divided by 12. So this I refers to nominal annual interest rate that is compounded monthly. Okay. And suppose if it is like quarterly interest rate is given, so 1 plus I quarterly interest. So in a year we have 4 quarters, and it is also, if it is also given like what is it, nominal there is a nominal interest rate of Y, which is compounded quarterly. So from that also you can that is also equal to 1 plus I effective. Okay, we'll make use of these formulas in our calculations.